Welcome dear students. So let's continue with the properties of determinants again. Okay, so basically from determinant chapter, this particular topic is a huge topic for you. Okay, because you come across various or different kinds of sums based on this particular topic. Okay, so the first question for the day is on the board. So using properties, we need to show that this is equals to this one. Now, whenever we have such kind of question, we see what is there? There is a factor, right? This into this, right? So in case of factors, what we need to do is we have to add the rows or the columns, okay, and check whether we get one of the factor or not after adding or subtracting the columns or rows. Okay, now let's see. If I add the rows, you get a plus x, x, x. That is a plus 3x. Do we have a plus 3x out there? No, right? We don't have a plus 3x. So let's add the columns then. So a plus x plus y plus z. Is this there? Yes. So that means the operation that you need to make here is what? The operation you need to make here is you have to write this column 1 as the sum of column 1 plus column 2 and column 3. So if I do that, let's see what do we get. So first let's write left hand side. So this is what we need to prove. Okay, this is what we need to prove. So left hand side is this. So if I apply this operation, then I'll get in the column 1 a plus x plus y plus z. So x plus a plus y plus z. Again this is a plus x plus y plus z, and similarly you get here a plus x plus y plus z. So others will remain as it is. You have y, a plus y, and you have y. Okay. Okay, outside, if you take out outside, you get a plus x plus y plus z, right? And you get 1 1 1 here, right? 1 1 1. This will remain as it is. That is y a plus y y z z a plus z. So this is what you get, isn't it? Now, have you seen this kind of sum earlier? Yes. So in such case, what we do is we will make these two zeros, right? So the operation that I'm going to make here is row 2 minus row 1, row 3 minus row 1. So row 2 minus row 1, okay, and we have row 3 as row 3 minus row 1. Okay, so let's do that. So we get this equal to, all right, so we have a plus, this factor is there. Let me write it as it is. Okay, all right, so I'm not changing row 1, so let me write row 1 as it is, 1 y z. Okay, so this means this is 0. Yes, this means this is a, isn't it? This means this is also 0. Okay, so let's do this also. So 1 minus 1 is 0, y minus y is also 0, and we have a plus z minus z is a, isn't it? Yes. All right, so we have a plus x plus y. Now let's expand. Okay, so we have 1 into, so determinant of a 0 0 a. So we need not check with this. If I write minus 0 and some determinant, this becomes 0 only. Similarly, plus 0 into some determinant will give you 0 only. Okay. Now, 1 into anything will be the same thing, right? Plus z is also there, right? So we have, this is equal to a plus x plus y plus z into, so this is a into a is a square minus 0, isn't it? So ultimately we got from here a square into a square minus 0 is a square, a plus x plus y plus z, and that's what I wanted to show here. Okay, so this is my equals to right answer RHS. Pause the video and note down your solution. So next we have a similar kind of problem which we have done in the earlier video. Okay, so this is equals to this and this is equals to this. That's what we need to show. Let's see how to prove this. So let me begin with this. Okay, so we have 1x yz, 1yzx, 1z xy. Now if you remember in yesterday's sum, what operation we did? We did the operation, this one. Okay, so let me first write down the operation for you. So first, okay, so let me not write operation. So let me make all these three same. Okay, so for that, what am I going to do is, I have to multiply this by x. So basically I will multiply this entire thing by x. Because I get x here, then it becomes x squared. X and x squared, they are also here. Okay, so multiply row 1 by x. Okay, so you get, so for that balancing, you have to put one x here. So it becomes x squared, and this becomes xy z. Right? Okay, so I want here y and y squared. So for that, you have to multiply with y. So you get y squared, and here it becomes xy z. So let me balance this by putting y here. Okay, so 1 will come here. Yes. Okay, so similarly, multiply row 3 by z. So you get z squared xy z. Okay. Now, see, what am I going to do here is, from this column, I'll bring xyz outside. So if I do that, you get xyz by xyz. Yes, so you get x squared 1, y squared 1, and z squared 1. Isn't it? Okay, but here, see, the order is something different, isn't it? So basically, I need to exchange the columns out here. Okay, so let's do the operation, that is changing operation. So first, you see, these two gets cancelled, so they are vanished now. Okay, so first let's exchange these two. Okay, so when you exchange column 1 and column 2, you know your sign will get reversed, isn't it? So it becomes, so the first column will be x squared, just wait a minute, this x is, oh, alright, fine. So x squared y squared minus z squared. Instead of this, you can change other columns as well. Okay, so this becomes, second column becomes xy z, and the last column is 1 1 1. Okay, so xyz is in the second column. That's okay. Now let's exchange column 2 and column 1 and column 3. Okay, so column 1 and column 3, if you exchange, again the sign will get reversed. That means this minus becomes plus now. Okay, so this becomes, so 1 1 1 comes in front. So I'm not changing second column, so xyz will remain as it is. Okay, and the last column is x squared, y squared, and z squared. So that's what I want to show. Okay, so first part is done. Now see, I want the factors, I told you, right? So whenever we want factors, let's see what observations or what operations can be done. So row 1, this gives you 0, this gives you y minus x, so this gives you y square minus x square. So y minus x, y square minus x square is nothing but y minus x into y plus x. So do we want y minus x? Instead we want x minus y, isn't it? Okay, so y minus x, if you get y minus x, obviously you will get x minus y also by taking out minus common, isn't it? So let me do this operation. So I am going to keep my first thing, this one, as it is. First row is going to be as it is. Now I am going to, so let me call this as 1, okay, because this is my one of the answer. So let me do this operation. So the operation that I am going to do here is, row 2 is row 2 minus row 1, and similarly we will write row 3, because this gives me, if I write row 3 as row 3 minus row 1, so the thing that I am going to get is z minus x, so z minus x is also there. So that's why this becomes, okay, so let's see what do we get now. So this becomes, all right, so the first row is as it is 1x x square, okay. So second row, so this minus this becomes 0, y minus x, and this is y square minus x square, okay. Similarly this minus this, row 3 minus row 1 becomes 0, z minus x z square minus x square. Now let's expand along the column, okay. So you get 1 into, okay, 1 into determinant of this y minus x y square minus x square z minus x z square minus x square. Okay, so let's quickly simplify this now. Okay, so 1 has no significance out here, okay. So y minus x into z square minus x square, okay, minus, so you get z minus x into y square minus x square, okay. Let's simplify. So we have y minus x, so this is your z minus x into z plus x minus z minus x y minus x into y plus x, right. See, y minus x and z minus x is common, right. So let me take it outside, common, y minus x into z minus x. So from here you have z plus x, right, minus you have this, so minus this becomes minus y minus x, right. This and this gets cancelled, right. Now z minus x is there, right, but instead of x minus y, y minus x, we have x minus y. So let me keep minus common here, so you get x minus y. So I don't have any problem with z minus x, as you all know. Now z minus y, but instead we have y minus z, so that's why again from here also I'll take y minus common, so you get y minus z, okay. Minus into minus becomes plus, so that's why ultimately I can write this as x minus y into y minus z into z minus x. So this is my second answer, okay. So you may pause the video and note down your solution. So next we have this one. So in the left hand side we have, okay, so determinant x y z x square y square z square x cube y cube z cube, right. All right, now is there anything common from each row and each column? Yes, so we have from this column x is common, right. So take out x common, okay. From second one you have y common, and from the last one you have z common, okay. So one of the factor is obtained now. So from here we get 1x x square when x goes outside, right. Similarly you get 1y y square, and similarly you get 1z z square, right. Now this problem reduces to the earlier problem that we have done just now, okay. So you want what? Okay, so let me do the same thing. So let me write column 2 as column 2 minus column 1, and write column 3 as column 3 minus column 1. Let's see what do we get here. So xyz is always present, so xyz is there, right. So we have column 1 I am not changing, so 1x x square, this will remain as it is. So you have 0 0, right, this minus this is 0, y minus x, okay. So we have x square y square minus x square. Similarly, you have z minus x, z square minus x square. Okay, so this will be equals to x, y, z. Now you can expand along the rows. Okay, so you get 1 into determinant of y minus x, z minus x, y square minus x square, z square minus x square. Okay, so I hope I need not do from here onwards. So x, y, z is already there. 1 into x, y, z will remain this much only. So we have y minus x. So let me do directly. Okay, so instead of this into this, instead of this I am writing z minus x into z plus x minus, so you have z minus x into this quantity, which is y minus x into y plus x. So here something is common, take them outside, some cancellation will be there, do the cancellation, some arrangement has to be done, do that, you'll get your final answer. Okay, so pause the video and complete the sum by yourself. We have yet another question which says prove that this determinant will turn out to be equals to this one. Okay, so that's what we need to show. So this is my left hand side. So let's start. So in order to get A, B and C, can I take common from each row and each column? So from column, yes, you can definitely take A common. From row also you get the same thing. Okay, so you take out from anything or anywhere. So let me take out from columns. So if you take A outside, okay, then you get minus A, B and C. So from second column you see B is common, so take out B, you get A minus B and you have C here. Okay, now next we have this one. So from here we get C as common, so we have, alright, so we get, when C goes, we have A, we have B and we have minus C, right? So that's what we have. Okay, now again, is there anything common from this column? And I'm sorry, this row? Yes, A is common. So if I take A, then this becomes A square, right? So this becomes minus 1. Yes, so this becomes 1, 1. Alright. Similarly, this becomes, if you take B common, then this becomes B square. Okay, and similarly from here, C, you take C common, you get C square. So this becomes 1 minus 1, 1. Okay, this becomes 1, 1 minus 1. Okay, right? Now, see here very, very carefully. So what am I going to do is, let me keep it as, see, it's your choice. Okay, so if you want to make this 0 and this 0, that's your choice. Okay, and if you want to make this 0 and this 0, that is also your choice. Okay, fine. So let's don't make your work complicated. So let me write row 2 as row 2 plus row 1, and similarly write row 3 as row 3 plus row 1. Okay, and let's check what do we get here. So this becomes equal to, so A square, B square, C square is already there, so I'm not changing row 1, so minus 1, 1, 1 is there, right? So we get this plus this is 0, so this plus this is also 0, 1 plus 1 is 2. Okay, so this plus this is 0, this plus this is 2, this plus this is 0, right? So this becomes A square, B square, C square. Now we have minus 1 into this determinant 0 to 0, right? Let's evaluate this now. A square, B square, C square minus 1. So this becomes 0 into 0 is 0, minus 2 into 2 is 4, right? So A square, B square, C square minus 1 into this is how much? Minus 4. So minus into minus becomes plus, 1 into 4 is 4. So ultimately this turns out to be 4 A square, B square, C square, and that's what I wanted, isn't it? So this is my right hand side. Pause the video and note down your solution. Okay, so let's have a look at the last question for the day. So question says, if A, B, C are all different, so they are not the same or not equal to each other, and this determinant is equals to 0, we need to prove this particular thing. Okay, so given is, see here carefully, so given is this determinant a cube, a to the power 4 minus 1, b cube, b to the power 4 minus 1, c cube, c to the power 4 minus 1 is equals to 0. Now, see here very carefully. Can I separate this into these two? Just see here carefully. So, a cube, I am just writing a to the power 4. So, b cube, c to the power, b to the power 4, c cube, c to the power 4. So, we have minus 1, 1, 1. So, let's write minus here, minus a cube, 1, b cube, 1, c cube, 1 equals to 0. Can I do that? Yes, definitely we can do that. Yes, and later on if you bring this out there, so this becomes equal to, okay. So write two steps, okay. So first separate this into this minus this equals to 0. After that you will take this over there and you will write this one, okay. Now something is common here, isn't it? Here in the first row a is common, so a is common from the first, from second you have b is common, from the third we have c is common. So you get, see here, 1a square a cube, right? 1a square a cube. So similarly from here 1b square, from here you get b cube. Similarly from here 1c square c cube. Okay, right? Okay. Now, if you want to work with this, that is also fine. Or else, if you change the rows, okay, if you change the, columns, if you change the columns, then you get this particular thing. Okay, so you get, see, first and foremost, if you interchange these two, this will come front, this will go back, and later on I'll exchange these two. Okay, so two operations, two exchanges are happening. So that's why first minus plus becomes minus, then after that, that minus becomes plus. Okay, so two operations together gives me, so first exchange these two, so this is going to come in the first column, okay. This goes to the last, but later on this comes to second one, so that's why this goes to second, a b c, and at last this comes to the last one, a cube, b cube, c cube. All right, now, so that's what we get. Now here, let's make this 0, okay. So the operation that I'm going to do here is make, what is this? Row 2, okay. So row 2 is row 2 minus row 1, and make row 3 as row 3 minus row 1. Okay, let's see what do we get now. So from here we get, so ABC is already there, so ABC, all right, so no change in the first row, right? So 1, so this minus this is 0, this minus this is 0, so a square, so b square minus a square, b square minus a square, c square minus a square. Okay, similarly you get a cube here, so b cube minus a cube, b cube minus a cubes, and similarly c cube minus a cube. That's what we get. Okay, is equal to, so same thing we can do here as well. So a cube will remain as it is, so this minus this is 0, b minus a, and b cube minus a cube. Okay, c minus a, so first and foremost 1 minus 1 is 0, c minus a, we have c cube minus a cube, c cube minus a cube. Okay, now let's expand along the column. So you get ABC, so no need to write 1, so you can directly write down the determinant, that is b square minus a square b cube minus a cube c square minus a square c cube minus a cube. Okay. Similarly, you can write here 1 into this determinant b minus a b cube minus a cube c minus a c cube minus a cube. Now, is there anything common here? You know the formula, right? So b square minus a square is b minus a into b plus a. B cube minus a cube is b minus a into b square minus ba plus a square. I am applying formula for a cube minus b cube. So basically from the first row I see that b minus a is common. So let me take out b minus a common. So we have a, b, c. So b minus a is common. Similarly from the second row we get c minus a is common. So you get from this b plus a, and as I told you, from here you get b square plus ba plus a square. Similarly from here you get c plus a, and from here you get c cube plus c square plus ca plus a square. Okay. Now similarly from here also you will find b minus a is common. So b minus a, and from there you get c minus a common. So you get this determinant. Okay, so we have 1 here. Here also you get 1. So this becomes b square plus ba plus a square. Alright. And from this you get c square plus ca plus a square. Okay. Now see here carefully. B minus a and b minus a can be cancelled because you know b and a, they are not equal to each other. So if they are not equals to each other, b minus a is not equals to 0, right? What am I trying to say is b is not equals to a, so that's why b minus a is also not equals to a, right? So in such case you can cancel, because we can cancel only non-zero numbers, right? So these two are non-zero numbers. 0 and 0 cannot be cancelled, remember. So non-zero numbers are cancelled. Similarly this and this also gets cancelled. Okay, so let's see what do we have now. ABC. All right, so we have, let's multiply this into this. Okay, so BC square, let's keep it in alphabetical order. All right, BC square ABC plus ABC plus a square b. Now with a, so plus a c square plus a square c plus a cube, right? Okay, so we have minus. Remember this wave is minus, so put minus. So let me write it here, minus. All right, so let's multiply with c now. So b square c, keep it in alphabetical order. So AB into C is ABC, sign will be minus ABC. Okay, C into this is minus A square C. Okay, now with A, now you get A, remember minus A B square minus A square B, A square B minus A cube. So that's what we get in the left hand side. Okay, so equals to, in the right hand side we don't have anything here, so this is c square plus ca plus a square minus b square minus, okay, so let me write this as ac and let me write this as ab minus a square. Okay, so let's see the things that are getting cancelled. A cube gets cancelled, so we have ABC and minus ABC gets cancelled, so we have a square c minus a square c, a square b, this gets cancelled, right? Is there anything left now? Is there anything getting cancelled? So b square, bc square, b square c, no, it won't get cancelled. Similarly here we see this and this gets cancelled. Okay, we don't have much space. Let's see whether we'll be able to accommodate this. All right, so we have ABC. Now B, from these two, from these two, what is common? Can I say BC is common? Okay, so if BC is common, then from here what is left? C is left, right? And from here you get minus B. Okay, now these two are done. Now we have this, right? So what is common here? A is common, isn't it? Only this thing is left. No, just wait. Yeah, these two and these two. Yes. So A is common. So if A is common, then you get C square minus B square. Right? That's all. So in the right hand side we have, okay, so C square minus B square, right? So C square minus B square is there. Okay. Plus you have from these two, A is common. So if A is common, you get C minus B. Okay. Now see, you have C minus B common in the both sides. Okay. So we have ABC into, so from here if you take C minus B, you get BC, right? BC plus C minus B is gone. So C plus B is left. So C plus B means A into C is AC, or let me write it this way only. So you have C plus B left. Okay. So from here you have C minus B is common. So from here C plus B is left, and from here only A is left, isn't it? Again, you know, B minus C minus B and C minus B, they can be cancelled. Okay. Now you have to open this bracket. Okay. You get this particular thing. Okay. And if you rearrange this, you get this one here. Okay. So that means whatever we are asked to prove, that can be written in the next step. Okay. So with this, we close for the day. You may pause the video and note down your solution. Thank you very much.